Okay, it is already 1 p.m. 7 minutes past 1 p.m. and in 11 p only two students, Hayato and Kevin. Okay, two students are on the list. Addition of two more. Hello, Dean. Hello, Janice, Kevin, and okay. Uh, right now, I'm going to continue the discussion of this one. Question number 3. When heated, iron trinitrate is converted into iron trioxide, nitrogen dioxide, and oxygen gas. Okay, and then 2.16 gram sample of iron of iron trinitrate was completely converted, or we call this is as a decomposition reaction. Okay, we call this one as decomposition reaction, and then completely into the production. Calculate the amount of the moles in iron 3 nitrate in 2.16 gram of sample. Give your answer to three significant figure. Okay, in this one, three significant figure. So let's see here. Okay, Hayato, Janice, Kayla already submitted. Okay, Hayato. Okay, this one, calculate the amount in moles of iron trinitrate in 2.16 gram of sample. So here, let me ask from Hayato.
Yes,
Hayato,
sir.
yes.
Yes, I'm here.
Hayato, in this question number 3,
Yes.
uh, question number 3, oh, question number, let me see. Oh, question number 3A1. You answer 0.00,
893.
yeah,
89.
yeah, 0.093. It is correct. Hayato is correct. I solved it
Uh, no,
using,
mas 369.
yeah. And then for this one, for this one, uh, for the next one is correct. The second one, include the amount moles of oxygen gas produced in this reaction, 6.7 times 10 power of negative 3. Correct. And then for the next one also correct. The volume, of the gas of the nitrogen dioxide is 1.26 times 10 to the power of negative 3. On your work, Hayato, I'm seeing there is you need to add unit. There
Okay, sir.
is no unit. Okay, there is no unit, and then this one, who's having this one, very small and written. Yeah, it's correct also. Yeah, 0 point. The next question is 0 is thermal decomposition, and then for C, there is easy to escape. Yeah, okay, that's correct. Yeah, but there is no name in here. Okay, I'm seeing all your work. This one 0 point. Okay, 0. Let me check first. 0.105 divided by 2. Okay, Nia and Kyla, with the value of this one, the value for your calculation, it should be for number 4A, number 4A, this one, the volume should be 0.0524. You wrote here Nia and Kyla 0.5. It's good that you already submitted. So Kyla, okay, yeah. And then for the rest of you, not yet. So like Kevin N, Kevin P, Matthew D, Shannon, Janice, Andrew, you have not submit the homework. It should be homework for you. And this one, let me see. Yeah, Hayato is correct, 0.0524. And then next, B in the second experiment. That the nitrogen monoxide gas produced in the reaction, calculate the amount of moles of the NO gas produced. It is correct, 0.026 mole. And then the equation, balancing equation, Hayato is correct. And then Hayato is correct. And then for this one, let me see, because it's correct also. And then next, Nia, Kaila also correct with the chemical equation balancing. And then for number C2, so I expect that you already did. So during the online, we are going to discuss only. Okay, suggest the yield is less than expected. As the reaction is not complete. Yeah, reaction is not complete, and then some of the nitrogen dioxide gas escape into the environment, and then it is next is difficult to separate the gases because nitrogen dioxide and oxygen gas, both of them are produced in the same reaction vessel. So it is quite difficult to separate. And then yeah, and then next, boron trichloride can be prepared as shown by the following equation. Boron trichloride number 5 here. So number 5, boron, calculate the mass of boron oxide that reacted for number 5. Number 5 here. Number 5, boron trichloride. Number 5. Okay. Number 5. Okay, let me see. NO 69.6. No, it is not. From 2.81 gram. Yeah, correct. And then for Nia and Kyla, also correct. Nia and Kyla, correct, 2.81 gram. And then boron trichloride can also be prepared from its element. Write an equation for this reaction. Explain why boron trichloride has trigonal planar with planar shape with equal bond angles. With equal bond angle because the same repulsion have 3 bond pairs repel equally, correct? And then C1 2.21, yes, correct. And then the chemical equation, correct with the balancing, and then for this, correct, there is no mistake. Okay, even until finished. So I'm going to discuss this question. Okay. Okay, I'm going to discuss this one. Stop sharing first. Okay, let me discuss this one. Okay, yesterday was until this number. Okay. 9 kilopascal. So in here we have to find the mole of the hydrogen gas. We divide 65 centimeter cube by 24,000 centimeter cube, and then we find the number of mole is 0.0027. And then we know that from the chemical equation, 1 ratio of X is the same as the ratio of hydrogen gas. So the mole of X equals to 0.0027 mole. So the molecular mass, we know mole by gram by mole. So we divide the gram of the X is 0.102. So 0.102 divided by the mole. And then we divide by the mole, we get as much as
Janice.
as much as 37.77.
Who did homework? Janice and Thailand.
38. We check all the possibility. Barium has the mass of 137, and then magnesium is 24, strontium is 87. So 38 is the isotope of calcium. How come like that? Because we know that isotope, they have different number of neutron, that makes different number of nucleon or different number of mass, but of course the difference is not very significant. Okay, this significant, what does it mean? We know that the mass is 38. So 38 is not the isotope of magnesium. Why? Because as we know, isotope, the mass is plus minus 2 or 3, not plus minus until 10. Okay, so this is the isotope of calcium. And then for this number 3, when heated, iron 3 nitrate with the molar mass of 241.8 is converted to iron 3 oxide, nitrogen dioxide and oxygen gas. So here we have the decomposition reaction of iron 3 nitrate. And then 2.16 gram of sample was completely converted into the product shown. Calculate the moles of iron nitrate. We know how to calculate the moles is mass of the sample divided by the molar mass. We get 0.00893 mole. And then the second question, calculate the amount of moles of the oxygen produced in this one. In this reaction is this one, we compare the mass, this one, the molar ratio, iron 3 nitrate is 4, while oxygen is 3. And then, so this number 0.00893 divided by 4 times 3. Divided by 4 times 3 equals to multiplied by 0.75. Get the mole of 0.0067. Calculate the volume in meter cube of nitrogen dioxide measured at 293 degrees Celsius and 100 kilopascal to produce. So here, if the gas constant is the same. So we calculate here. We have to convert all the information. What are the informations? Temperature and pressure. Temperature we have to make into Kelvin, and then pressure we have to make into Pascal. And then moles of NO2. How do we know moles of NO2? The moles of NO2 is based on the molar ratio is 12 or 3 times of this one. So 0.00893 times 3. So become 0.02679 or round off become to 0.0268 to the nearest number. And then this one, so the formula we have to calculate using P and RT, and then the V equals to N times R times T divided by pressure. And then we do the calculation. Here we find the volume to be 0.0012 Okay, so we found this one, the volume of the volume of nitrogen dioxide. Okay, the volume of nitrogen dioxide 0.00126, and then if we calculate the number of moles, this one, what is happening with this one, this calculation, if you are not able to find the moles of iron trinitrate, as if the moles of iron trinitrate is 0.00642, and then this is multiplied by 3, found to be 0.0193. So this one, in condition that you cannot find the other questions, the answer of the other questions. Suggest a name for the reaction. This is called as thermal decomposition, as we know and we learned already in grade 10 HCSE chemistry class. And I suggest why the iron 3 oxide obtained is pure. Assume a complete reaction. This one, iron 3 oxide is pure. Why? Because other products are gases, so other products are escapes. This is, as we know, if it is complete reaction, or the iron 3 nitrate will convert it into iron 3 oxide. Because these two are gases. Nitrogen dioxide gas, oxygen is gas, so they escape into the environment. Okay, and then now next, page 3. The metal lead reacts with warm dilute nitric acid to produce lead 2 nitrate, nitrogen monoxide, and water according to the following reaction. So this is the chemical equation. The mole ratio, lead is 3, nitric acid is 8, and then lead 2 nitrate is 3, nitrogen monoxide, and water molecule. The question here in experiment, 8.14 gram of sample lead reacted completely with 2 mole per liter of nitric acid. Calculate the volume of nitric acid required for the complete reaction. This is this one we already learned in chemical calculation in grade 10. I'm sure you are able to do this one. Okay, so there is finding the mole first, and then we have to do the stoichiometry, and then after stoichiometry we find the mole of the this one, mole of the nitric acid, and then mole of the nitric acid divided by the concentration of the nitric acid, and we get the volume. In a second experiment, the nitrogen monoxide gas produced in this reaction occupied, this is the volume, this is the pressure, and this is the temperature. We have to find the mole. So we have to do PV and RT. In order to find the N, P times V divided by R times T. So we using this one, this formula, and then we get 0.026 mole of nitrogen monoxide. And then when lead nitrate is heated, it decomposes to lead oxide, nitrogen dioxide, and oxygen gas. This is the equation is already given. We just need to make it balance. Of course, you can make it balance. Suggest one reason why the yield of nitrogen dioxide formed during this reaction is less than expected, because it is there is a impurity of nitrogen of lead to nitrate, and then decomposition process is not complete, and then some of the nitrogen dioxide gas escapes into the environment. So in order to find the yield 100%, we have to make sure that the purity of the lead to nitrate is 100% pure, and the composition should be complete. Next question, page 4. Suggest one reason why it is difficult to obtain a pure sample of nitrogen dioxide from the reaction. It is quite difficult to separate oxygen gas from nitrogen dioxide because nitrogen dioxide is considered to be a pollutant, and then in order to separate both of them, then we have to do fractional distillation, and if we do with water displacement also cannot. Why? Because nitrogen dioxide, it is soluble in water as well as oxygen gas. If we do upward delivery or downward delivery, it would have the same or similar result. So it's quite difficult to separate to calculate the nitrogen dioxide alone from this reaction if we do not do fractional distillation. Now, number 5. Boron trichloride can be prepared as shown by the following equation. Boron trichloride, and then plus carbon plus chlorine gas become boron trichloride, and then plus carbon monoxide. A sample of boron oxide was reacted completely with carbon and chlorine. Now this is the volume, 5,000 centimeter cube, and pressure of 100 kilopascal, temperature of 298 Kelvin. The question is asking for the mass of the boron that reacted. So we know the volume, and then we have to use the formula of PV and RT. Why? Because the information given here only the volume, pressure, temperature. From, of course, the R is constant 8.31, so we have to find the number of mole. From number of mole, we can derive from gram of mole, we can derive the molar mass. The molar mass, and then we can get the mass. Okay, and then from this one we know that the mass is 2.81. Then P, boron trichloride, can also be prepared from its elements. Write an equation for this reaction. Why boron trichloride has trigonal planar with the equal bond angle? Okay, we write an equation prepared from the elements. Boron plus chlorine gas. The chlorine gas should be 1.5 mole, become boron trichloride. Boron trichloride has 3 bond pairs and 0 lone pair. We know that lone pairs repel the most, but in here there is no lone pair at all. So these 3 bond pairs will repel the least, and then they make the equal repulsion, which is 120 degrees. Okay, so this is the question, and then number C. Boron trichloride is easily hydrolyzed to form 2 different acids as shown in the following equation. Calculate the concentration of the hydrochloric acid produced when 43.2 boron trichloride are added to water to form 500 centimeter cube of the solution. So in here we have to find the number of mole of boron trichloride, and then we do stoichiometry, and then after we do stoichiometry we find the mole, and then mole divided by the volume, then we get the concentration. Okay, so next question, number 2. This one, boric acid can react with sodium hydroxide to form sodium borate and water. Write an equation for this reaction. So this is already written the word equation. We have to convert into the chemical equation, and also do not forget to balance the equation. Okay, so this one, a different compound, boron and chlorine, has relative molecular mass of 163.6 and contains 13.2% of boron by mass. So this is the finding the empirical formula. After finding the empirical formula, we have to find the molecular formula. Okay, we had never done this type of question when we were in grade 9. Okay, so this number 6, ammonia is used to make nitric acid by the Oswald process. 3 reactions occur in this one. So ammonia react with oxygen to form nitrogen monoxide and water molecule. Nitrogen monoxide react with oxygen to form nitrogen dioxide, and nitrogen dioxide reacts with water again to form nitric acid and also the nitrogen monoxide again. Why shouldn't we react with oxygen here? When not react with excess of oxygen, because the reaction could be very exothermic. Okay. In the production run, reaction 1 occupied total volume. So this is the volume, this is temperature, and this is the pressure. Of course, the question is asking for moles. Then we have to use the formula of V and RT. Do not forget the pressure must be in Pascal, temperature has to be in Kelvin, and then volume has to be in meter cube. And then the meter cube, then we can find the number of mole. Okay, and then B. In another production, 3 kg of ammonia were used in reaction 1, and all the nitrogen monoxide gas produced were used to make nitrogen dioxide in reaction 2. Calculate the amount of moles of ammonia in 3 kg. So we have to find the number of moles first. The number of mole is 3000 divided by 17. Why 3000? Because 1 kilogram is 1000 gram. And we know that the molar mass is gram per mole. And then, so the answer should be 176.5 moles. Okay, so roughly around that. Okay, next. We are on page 8. Calculate the mass of the nitrogen monoxide formed from 3 kg of ammonia in reaction 2. Assume that the percentage yield is only 80%. So here we have to find here moles. This is moles. Moles of this one, and then moles of nitrogen monoxide and nitrogen dioxide found to be 8117.62. And then this one, this is assumed to be 100%, and then we have to find it is 80%. So this is the answer, and then we have to find that it is in gram. Then we have to convert in kilogram. Okay, and then C. Consider reaction 3 in this process. Nitrogen dioxide reacts with water to form nitric acid plus nitrogen monoxide. Calculate the concentration of nitric acid produced when 0.543 mole of nitrogen dioxide is reacted with water and the solution is made up to 250 centimeter cube. So here we have to do, we know that the mole of nitrogen dioxide is 0.543, and then the mole ratio, this is 3, and then the question here, nitric acid is 2, so 3 and 2. So this one, 0.543 divided by 3 and then multiply by 2. We get this much of mole. And then, this much of mole, we have to do multiply by 1000 divided by 250. Why? Because this one mole per decimeter cube. So this 1 centimeter cube must be converted into decimeter cube. So the answer should be 1.45 mole liter or near to that. And then we are on the last page. Suggests why a leak of nitrogen dioxide gas from Oswald process will cause atmospheric pollution. Because the nitrogen dioxide, we know it is a source of acid rain. It causes nitrogen, nitric acid to be formed in the atmospheric pressure and the atmospheric condition, and then also it can cause pollute the lake water, and then that endanger the aquatic life. Suggests one reason why excess air is used in the Oswald process to ensure that all the nitrogen hydride or ammonia is used up for the complete conversion to make the yield of the nitrogen dioxide to be 100% and the yield of the nitric acid to be 100%. Ammonia reacts with nitric acid as shown in the equation here. Reduce the time of the reaction occurring. Here, of course, this is neutralization. Why? Because this is ammonia, this is nitric acid. Ammonia is a base and nitric acid is an acid. We know based on the Bronsted-Lowry and Arrhenius definition of acid. Acid is a proton donor and base is a proton acceptor. So from NH3 here become NH4 positive, and then NO3, HNO3 will become NO3 negative here. So the nitric acid has lost its proton, while the ammonia gets a proton. This one is ionic bonding and also covalent bonding. In here,